All right, hi everybody. We are now on to Unit 4, Presentation 2. So last week we learned about how density can predict whether or not something is going to sink or float. So this week we're going to talk same thing, what makes something sink or float, but instead of talking about density, we're going to be talking about buoyancy or buoyant force. All right, so let's get started.
First thing is we need to know what is buoyancy. All right, so we kind of talked about it last unit when we went over briefly about the 7 different forces, and buoyancy was one of them. But in last time we talked about was that it is an upward force that a liquid pushes on an object. All right, and again, remember we should have our highlighter out when we take notes. And every object has a buoyant force, whether it's really tiny or very, very large. Because anytime you put an object into liquid, you should always see that water level rise. And whenever that level rises, that's the buoyant force of the object, because the water or the liquid is pushing up on the object. And when it pushes up, the water level rises. Okay, so that's what buoyant force is. So whether it sinks or floats, the object always has a buoyant force. All right, now, how do you find it? Okay, it's very similar to finding volume. The only difference, so we're going to do water displacement. All right, when you're finding buoyant force, the only difference is this. Okay, buoyant force is measured by finding the weight of the water displaced. Last week when we found the volume, you put whatever that water came out of the overflow can, you put it in the graduated cylinder to see how many milliliters, right, that object was. That's by finding the volume. Okay, when you're finding the buoyant force, what you do is you still get the displaced water just like we did last time. So we put an object into the overflow can, and what you do is instead of putting into the graduated cylinder, you're actually gonna weigh. So you're gonna weigh the water that came out. So this time, instead of pouring all the liquid into a graduated cylinder, we're gonna put that right onto the scale. So this time, the tool that we need is a scale. All right. So if you look at the picture right here, right, this is what I'm talking about. So here's the overflow can right here, and so when you put the object inside, water is gonna spout out. Right. In this case, when you find the weight of that water, it ended up being 3 pounds, right, of that. And that's the other thing too. If you look up here, let's say the object was 7 pounds, and when you put it in water, all right, whatever also the weight of the water that's displaced, if you add that with the actual weight when it's in the water, they should add up to be what it is on the outside. So in other words, this is the reason why water, or whenever you place an object in the water, it feels lighter, because the water is helping you lift it up. Okay, so if let's say something let's say weighed 200 pounds on land, so it's really hard for you to carry, right? But let's say you put it in water and it has a buoyant force of 150 pounds. That means that you're really only lifting 50 pounds in the water. So it's so much easier to lift because the water is helping you lift it up. So that's kind of like what buoyant force is. So how does it tell us then that an object will sink or float? Well, if we can find the buoyant force and the weight of an object, and finding the weight is pretty simple, right? You put it on the scale, and to find the buoyant force, we just need an overflow can. But how can we predict if something will sink or float? Well, if the buoyant force is more than the weight, it's going to float. Okay, so if you look at the picture right here, so in other words, if this force, right here, if this force is bigger, so if this is bigger than the weight, it's going to float. Obviously, if you look at the picture, what's pushing up on it is stronger than what's pushing down on it. It's going to go up. And what do objects that float do? They go up. Okay? And then the other one, if the buoyant force is less than the weight of the object, it's going to sink. So again, right, if the weight is bigger, so in other words, if you look at the picture, and this is the great thing about looking at force arrow diagrams, is it tells you which direction it's going to go. So if this weight, right, if this force is stronger, that means that the downward arrow is stronger, it's going to go downwards. And what do objects that sink do? they always go down, right, until they hit the bottom. So that's how you can tell if an object is going to sink or float. So if we know those two things without putting it in the water, you can tell if an object's going to sink or float. All right. So let's do one for example. Let's say the Coke can from last week, right? When we did the demonstration, I showed you that Coke can sinks in regular water. So let's draw a force arrow diagram for that. So let's say that the object's weight. So Coke can, and I did this before. It has a weight of 355 grams, right? And I know that the object's buoyant force, so the Coke can's buoyant force is 335 grams. So the way I would draw a force arrow diagram is, again, I need to know that the weight of the object is the one that goes downwards. So I'm going to draw an arrow that goes down. And yes, you do have to draw this. I'm assuming that a lot of you guys are probably asking me that question right now. All right, but I want you to draw it. So remember, shouldn't be new since we did this in Unit 2, drawing the force arrow diagrams. And then it has a buoyant force of 335 grams, right? And if I remember from last unit, it should be a little bit shorter than the one that's going down because the force is a little bit less. So the arrow should be a little bit shorter than that one, right? Now, just by looking at that, you should already know whether or not the object is going to sink or float, right? I know that this arrow right here is bigger, which should tell me, right, that the object is going to sink. Therefore, when I do my net force, and again, we did this last unit, right? It's 355 grams minus 335 grams, which equals 20 grams. And again, remember, with the force, you have to tell me which way it's going. And since it's going to sink, it's 20 grams down. All right? So that's my net force. My net force is 20 grams down. So when I actually put it in water, right, when I try to lift it up, it's going to feel like 20 grams in the water. All right? So that's how I do force arrow diagrams for this unit. So things are, remember, in this one, we're only going to have up and down arrows because of that. All right? So it's pretty simple, a lot easier than last unit where we had maybe arrows going all different directions. But this is how you do the net force. So we've got the right net force equals. Okay, so that's nothing new.
Increasing buoyant force, presented by Buoyancy Productions. In this activity, our goal is trying to make this object, a ball of clay, which normally, in water, when you place it in there, sinks right to the bottom. Our goal is try and make that little thing called a ball of clay float by increasing its buoyant force. Okay, so the first thing we need to do is we need to find the buoyant force of our just clump of clay using this little contraption right here. We got a 2-liter bottle with a little tube sticking out. And the way we're going to find the buoyant force for this one is when I drop this in here, the water is going to be displaced. It's going to go up. And what this styrofoam cup is going to do is it's going to catch the water displaced. And then later, using this trusty little scale here, we're going to weigh our water display and find a buoyant force. So here we go. Okay, now that the water is all done dripping out of there, we can take this and we can weigh it to find the buoyant force. Now, as you can see from right here, 74.28 grams is our buoyant force of that clay. Now, our next goal, after we found the buoyant force of our clay, was try and figure out, what can we do to this clay to figure out how to increase its buoyant force? Now, after trying to do several different types of shapes, we later learned, bam! A bowl shape really worked. Because if you put it in water, voila! Now, another way we can find buoyant force, not only can we use this contraption, but simple thing is adding weight to it is going to do the job. So what I'm going to do now is add the weight until it finally sinks, and then we're going to use, again, our trusty buddy right here, our weight scale, to weigh out the stuff so we can find the buoyant force. All right. Okay, now that my cup sank, I can take this, I'm going to make sure I dry off everything so I don't get the weight of the water on here, and I can put it on my weight scale to see now its new buoyant force. Look at that, 153.45 grams. We were successful. We were able to create something, take the same exact clump of clay and turn that into a more buoyant force that can float. Okay. Now that we figured out, hey, a bowl shape works, that can increase the buoyant force, we're left with another challenge. Now, how can we take this and make even more of a buoyant force? So we had a challenge, tried a few shapes, and this is what we realized. We came up with something like this. What's the difference between the two? Well, this is now bigger. We think that making it bigger, all right, having more space inside for air, that's going to create more buoyant force. Let's find out. Now that I got the bowl out of there, made sure I dried all the pennies to make sure that there would be no water weight to it. I put it on the scale. And there you go. Again, 200.24 grams. That tells you that our buoyant force increased. So we were successful in our job. So, in conclusion, we can say that to increase the buoyant force of our clay, all you have to do is first make a container. Okay? Have it filled with air. And to increase the buoyant force even more than that, you got to make it bigger. Make that container as big as possible, and there you go. You have just now increased the buoyant force. Thank you very much. This is Mr. Roseni's production.